the effects of caffeine in children and adults is really the same. So inside of our cells, we have our cell. So if you think about our bodies, it's just a manifestation of trillions of little cells, right? So every cell in your body, it takes in nutrients, it does work, and it produces waste products. And you as a person, obviously, you take in food, you do what you do during the day, and you produce waste, right? And you breathe out waste, you urinate, defecate, like all this stuff is getting rid of waste products. So every cell in your body is doing exactly the same thing. Now, the energy of every single cell in our body is the same, and it's something called ATP, adenosine triphosphate. So it's an adenosine molecule that has these 3 phosphate groups on them, and every time you cut one of those phosphates off, it causes this big burst of energy, and then that energy gets used by the cell to do whatever that cell does. A liver cell does something different than a heart cell, that does something different from the brain cell, but they all do their own thing, but they all use ATP. Now, ATP, once you take off one of the 3, it becomes ADP. So it's adenosine triphosphate, diphosphate, monophosphate, and then eventually it's just A, and that's just adenosine. Now, pretty clever mechanism. Over millennia of evolution, it takes a certain amount of time to recover from being awake and active a certain amount of the day. The more active you are, the fewer hours that you can be awake without needing to recover. But the overall balance in general is about 16 hours of wakefulness, 8 hours of sleep, 16 hours of wakefulness, 8 hours of sleep, and this just repeats every day, every day. If you're a lot more active, maybe it's 9 hours of sleep and 15 hours of wakefulness, or you get the idea. But what causes the sleep pressure, what we call sleep pressure. So sleep, there's not an active process for going to sleep. There's not like, we're going to produce a ton of this and it's going to make you fall asleep. There's a ton of hormones and neurochemistry that causes you to be awake. And what we do is we take away the wake promoting neurochemistry. And once we take away that, the alternative is to be asleep. So really, being asleep is the absence of being awake. I mean, it's rhetorical, but that's the fact. So adenosine, once you go from ATP to ADP to AMP to just A, you just have adenosine, that tells your brain, we've burned it out, man. Like, we have a ton of this adenosine we need to restore. We need to turn all these A's back into ATP. And so we have to do a bunch of regeneration. We have to balance the way we're using our fuel. And so we need to go to sleep and recover. So when you're young, you tend to be a lot more active. You're learning a lot faster. You're a lot more physically active. You're learning physically, you're learning cognitively, and everything that you do that's requiring energy is burning up ATP. And adenosine causes the sleep pressure. All caffeine does is it blocks the receptor. So if this is an adenosine molecule that's floating around to tell your brain that there's a lot of us around, we need to recharge, and this is the receptor that it grabs into, well, caffeine will come and block that. So then this can't bind. And it doesn't stimulate this receptor the way the adenosine does. And so when you put caffeine in there, what you're really doing is you're blocking your normal physiology from saying, now it's time to recover. And you're just delaying that and you're pushing it down the road. When you're young, you actually improve. Every night you go to sleep, you wake up better. You wake up stronger, taller, faster, smarter. As we get older, we're just trying to not decay, right? At some point you quit growing and then you start going down, and then you're not getting quite enough sleep every night to wake up 100% the next day. So in children, it's much more important for their sleep pressure to be the director of when they sleep. So if you're using caffeine in a child, you're interfering with their normal trigger for when they should be going to sleep. You're doing the same thing in an adult, but in an adult, it's pretty much 16 and 8. If you're living sort of your normal lifestyle. And a child, it could be drastically different. Like, a child needs 9 to 12 hours. what determines 9 to 12 is the adenosine. So I would not recommend caffeine in children just because you're messing with the normal machinery that's going to dictate how much sleep they need, that's going to dictate how much they recover and how much they grow and how much they come back the next day ready to do whatever it is they do.